Hey YouTube, something I've noticed as I've made Scratch projects over time is that a lot of times what sets apart good projects from mediocre ones is the attention to detail and the little subtle things that you do to make them better. And I've got one trick here today that I think can be really useful in turning a sort of a mid-level project into what seems like a really high quality one. So I've got here a small example where I have a menu in a game that I've created using a glide blocks that the buttons will animate in, and then when you click them, they will animate out. And on the surface, this seems pretty good, right? We've added some animation to our game. It's not just static buttons appearing and disappearing, and that seems like a perfectly solid solution. But I've actually got a better option, which is to use springs. Now, I don't mean literal springs, but there's a mathematical model that you can use for springs that's actually really useful. So if I click the green flag here, you can see that the button sort of springs in and wobbles back and forth in a way that feels consistent, and it flows in a much nicer way than the glide block did. So again, if we click this, you can see the buttons sort of animate in and then animate out in a really nice, smooth way. And also, you can sort of stop these animations mid-flight by clicking the button early, and everything is just handled gracefully. It turns around smoothly and just generally looks really nice. So this is something that's quite useful and that I think can be used in a lot of different ways. But it's actually not just like one-dimensional motion or animating to and from a position. You can actually animate towards a thing just in general. So here I've got a cat that's going straight to my mouse. I'm just saying forever go to mouse pointer. This is the exact match method, which is pretty boring. But if I switch into spring mode here, you can actually see it looks a lot smoother and a lot nicer. Now, this doesn't necessarily have a practical application directly, but I think you can imagine how this type of smooth motion might be useful in your own games. And it's not just the mouse that you can follow. You could also have things following each other, right? Maybe you want to have particle effects surrounding a player, right? And they could move to the player using this nice springing motion. But it's also not just the position of a sprite that you can animate. You can also animate other things. One example I have here is its size. I've got a spring physics controlling the size of this. So you can see as I move my mouse right and left, the circle changes to a different size depending on the position of my mouse. But it's doing it in a nice smooth way where if I turn around quickly, the circle still does it smoothly. So these are just a couple different examples of the exact same mathematical techniques being applied in different ways. So I want to show you how to program this and sort of how we can use it in our own projects to make them better. Now I've opened up the Scratch editor, and what I'd like to do is recreate the project that we just saw where there was the Scratch cat following the mouse pointer around the screen in a nice smooth way using these spring physics. Now the original solution that I showed was to have the cat just forever go to the mouse pointer. And of course this is not a good solution. It's not springy, it's not smooth. So what we want to do is somehow make it ease towards the mouse, that rather than jumping immediately to it, we just sort of go part way there and just do a partial move lots and lots of times over and over again. So one thing that we can try is to say that rather than going to the position, we're going to change our x and our y. We'll start with just x. We want to change our x so that we move, for example, 10% of the way there, right? If every single frame we move 10% of the way from the sprite to the mouse, we get 10% closer. Over time, you'll get closer and closer to that mouse, and it'll actually make a pretty smooth motion. So what we want to do first is measure the total distance, right? What's the distance between my current x position and the mouse? So I am going to take the mouse x, which is where I want to get to, my target coordinate, and subtract away what I currently have. And that's going to tell me how far do I need to move in order to get from my current x position to the mouse's x position. Then what I want to do is say, hey, rather than moving the entire way, which is what this will currently do, you can see it's basically the same as set x to mouse x, right? I'm just moving 100% of the way to the mouse's x coordinate every time. What I want to do instead is say only move maybe 1/10 of the way there. And I'm going to do that by multiplying by 0.1, which is the same thing as dividing by 10 if you prefer to do that instead. Now I'm going to zoom out a little so that you can see the whole script, but you can see there that I've got this. And now, as I move my mouse, this scratch cat follows smoothly. And I'll move it down here so you can see better. As I move the mouse, the scratch cat follows smoothly. And this is pretty nice. And we can actually do the exact same thing for the Y coordinate. So I just say change the Y position. And then what we want to do is take the mouse Y minus the current Y, which gives us the total distance that we need to move in order to get directly to the mouse. And then say actually only move about 10% of that. Only move a tenth of the way there. Or multiply by 0.1. And when we do that, we'll get this complete smooth movement from the cat to the mouse. Now this is pretty good, but it's actually not the same as what we had in the spring version. The reason being that there's no overshoot. The scratch cat can never go too far past the mouse and then come back, which is something that we saw in, for example, the spring menu. It'd go too far. The buttons go past the target position and then come back. But here, we don't have that, because we're only moving 10% of the way every time. You'll never move too far. There's also the problem where if we're going one direction and then suddenly need to change directions, so if I'm going here and then need to change, it happens instantly in a way that's not as smooth as we'd like. So, a couple problems to fix there. And the main thing that we need to do is not just move 10% of the way, but to actually remember how quickly the cat was moving before and continue moving that quickly and just sort of accelerate in a different direction. So, let's say that the cat is moving towards the mouse. It should sort of overshoot by remembering that it's going fast and continuing to go fast until it can eventually slow itself down. The same way that if you were running really quickly at something, it would take you a second to kind of stop and turn around after you overshoot it. So how are we going to remember this speed? Well, in order to remember information, to keep it stored in memory, we're going to need a variable. Now I'm going to start by doing only the x, just like we did in the beginning. So I'm going to call it xvel, which stands for x velocity. Velocity being sort of a measure of the speed in a certain direction. So I'm going to also mark this variable as for this sprite only, since if we were making this in a game, you would only need this variable in this sprite. Now, I've got my variable, and I'm going to start the project by setting it to 0, just to sort of reset things. Then what I want to do is say, hey, rather than changing your x by this amount directly, change your xvel by that. So instead of changing our exact position, we're actually going to change how quickly we're moving to go towards the mouse. Then we're going to change the x by the xvel. Now this is going to take a second to kind of wrap your head around, but you can see it overshoots. It definitely overshoots, but it maybe overshoots by too much. So this is something we'll have to change. But you can see it targets around the mouse. If I move my mouse, it will follow it. It just does so in a very overshooting kind of way. And the thing to remember here is that now, rather than our cat moving towards the mouse, the velocity sort of points towards the mouse. And the velocity moves smoothly, and then the mouse, or the cat follows that velocity. So again, it's a little tricky to wrap your head around, but we're getting there towards the right solution. Now, the other problem, of course, is that he keeps going forever. The cat just continues to bounce back and forth with no end. So what we'd like to do is sort of introduce a little bit of friction, or what we call in spring physics, damping. And the idea here is that we're just going to sort of slow the cat down at all times by a little bit. And the great thing about this is that it will actually naturally lead to our cat slowing down right at the mouse coordinate. So I'm going to say after we change the x velocity to make us sort of move towards the right direction, also slow that x velocity down by making it maybe 90% of what it was before. And the way we can do this is just by multiplying the current x velocity by 0.9. That says take 90% of the current x velocity and make that be the new x velocity. Now if we do both of those things, you can see that we start to get a nice smooth motion, where the cat moves towards the mouse, but then slowly centers in on the right position. Now, this is exactly what we want. We've got the spring physics here that are working as intended. The only problem is that it only happens on the x-axis. So we're going to kind of go through the same process again. Right now, even if we do this, our y can't overshoot, which actually it's a weird thing to do the combination of both methods. But the y can't overshoot while the x can. So in order to allow the y to overshoot, we have to sort of remember how fast it was going before. And the way that we do that is with the y_val variable, again, for this sprite only. Once we have the y_val, we want to reset it when we start the project, and then say, okay, every single frame, change the velocity so that I'm moving towards the mouse pointer, or accelerating towards it. And the way, whoops, I can't do it like this. The way that we're going to do this is by taking the mouse y, which is where we want to go, minus the current y position, which is where we are right now. And this will tell us how far do we need to move, in what direction, in order to get to the mouse. Then we say, actually, we only want to do about 10% of that, or 0.1 times. And we're going to change the y velocity by that amount. Now again, we want to change our y by our y velocity. That just means use the velocity to actually move. And the last thing we want to do is apply the damping, or the friction, which basically just says, take the y velocity and constantly make it 90% of what it was before. Multiply it by 0.9. You can see this script is almost identical. This part is almost identical to the first part. The difference is being that we've replaced all the x's with y's. And by doing both of these things, we can now have our cat sort of spring towards the mouse. And you can see there's a lot of overshoot happening, and then it takes a long time to correct, which is actually a nice exaggerated example of the spring physics. In practice, you generally wouldn't want it to be this extreme, but it's a nice example to see. Now, as we said, it's too extreme. How are we going to make these spring physics less extreme? Well, it's actually up to these two numbers here, this 0.9 and 0.1. And we have these numbers copied in two different places, and we always want them to match up. This number should match this number, even if it changes. So I'm going to make a variable to keep track of it, and then we can have both be the same at all times. Now, the first variable, I'm going to call, well, we could call it friction. I'm going to call it damping. And this is, again, sort of that how much it's slowed down. I'll make it for this sprite only again as well. You don't have to. It's just for fun. Now, this damping is going to be the 0.9 number. So right now I'm going to actually set damping to be 0.9 and then plug it in to this location. Now the great thing about this is that we can turn it into a slider where we can change the damping any amount we want. So I'm going to set the minimum on this slider to be 0.0 and the maximum to be 1.0. And the reason I include those point zeros rather than just the numbers 0 and 1 is because they force Scratch to actually allow us to set all of these values in between rather than just having 0 or 1. So if we set our damping to be 0.9, you can see nothing has really changed, right? But we can now change this damping, and it'll affect the way that our spring physics work. So if I make the damping really small, you can see the Scratch Cat is now slowed down a lot by friction, right? And if we make it 0, the Scratch Cat can't move at all, because the friction is saying, take your velocity and multiply it by 0, right? Make it absolutely nothing. And if we set it to be 1, it means overshoot forever, because there's no friction to slow you down. So you'll generally want to be somewhere in between these values. Less than 1/2 is going to make it very slow. Somewhere around maybe 0.8 will be nice in a lot of cases where you get a little bit of overshoot, but not too much. But this is a number that you can really play around with for yourself in order to make the physics work exactly how you want it to. Then we've got this number here, which is sort of the tension of the string, or how sort of firmly it moves towards the position that it wants. I'm going to call it tension, although again we can call it whatever we want. Now I'm going to plug this variable in for 0.1 here and 0.1 here. We'll zoom out a little again so you can see everything. And then, again, I'm going to make this a slider just so that we can play around with the values and it'll give us a better sense of what's going on. Again, I'm going to use 0.0 and 1.0 because those are the kinds of values we want to be in between. And I'll set this to about 0.1 like we had before. Now the idea with this spring tension is that if I increase it, the cat will move more quickly towards where it wants to go. And you can see it kind of moves firmly in that direction, but then it overshoots a lot. And the higher this is, the more rigid the movement is going to be. And of course, if you're at 0, it won't move at all. If you're at 1, it'll move a lot. And we can go anywhere in between. Now, this really just means that now we've got these two variables to play with, and this is all that you have to do to change your physics. So if you increase your damping, well, you'll end up with no friction. If you decrease it, you end up with lots of friction. So a low damping and a high tension will give you quick movement with not very much overshoot, where a high damping with low tension will give you slow movement with lots of overshoot. So we could go even slower here and higher. And if I can do this, you can see we've got slow movement with lots of overshoot. And those are sort of the two different variables that you can change. So again, tension is sort of the speed of the movement, and damping is how much overshoot you're going to have. So here we have very little overshoot. And it's a lot of fun to play with these values. You can see I'm already getting lost myself, just having so much fun messing around with these. If you create a project like this for yourself, it's a lot of fun to play around with. And do remember that it's not just the x and y coordinates that you can change. You could also change other variables or other values just by replacing the change x by and the x position here with the value that you want to change. So maybe you have a variable or you want to change the size or something like that. You can replace these blue blocks like that. And this mouse x and mouse y, these are going to be your target values, right? So in the spring menu, for example, I have a target x. And at the beginning, the target x is 0, which means go to the center of the screen. And when you click the button, that target x becomes 360, which means go way off to the side. So this is sort of that same idea where I'm plugging that target value into that position. So that position in the script is where you put the target value, what your spring should aim to hit. I think that pretty much wraps up everything. If you have questions, feel free to let me know. Do share in the comments if you have projects using this or examples of cool things that can be done. I'm excited to see what people create, and let me know how this works for you.